Okay, thank you for everyone who has hung in there for part 3. Really all we have left, it should be short and sweet here. We just need to find member AC internal loading. So it should be, like I said, short and sweet. What we're going to do, this method of joints, what we do is we draw the same idea like we did last time, the free body diagram, but instead of the FBD at B, we're going to do it at joint A. So I'm going to call this M of J, method of joints at A. Okay. So what that looks like, we'll draw our free body diagram here. There's joint A. We have RAX. It's a roller, so we don't have any vertical reaction forces. And we have AC. Again, we assume AC as a tension force, so that points away from the joint A. And we have AB. AB we found was a zero force member, so I mean I'll still show it right, like that, but again it's a zero force member. So free body diagram, pretty short and sweet. In fact, when we go to do this, we're going to find that we only want to find the sum of the forces in the x direction because there's no force of member AC that's directed vertically. So the sum of the forces in the x direction sum to 0. And the only forces we have are RA in the x direction and AC. Now, right now we've assumed tension, and RAX we already found previously, video 1, that was pointing to the right. So RAX is to the right. We're assuming AC is to the right. So we can tell right now that something's not going to bounce or balance out. We need to move. Let's see. Well, we found RAX was 50. So 0, we'll sub that in, is 50 plus member AC. Now what's nice is AC is AC. We don't have this angled force where we have AC in the X or AC in the Y. We have just AC. So when we move this over, we find that AC is equal to negative 50. Well, again, negative 50 doesn't mean anything to us directly. What it really means is that AC is a 50-pound force in tension. So, in the end, so I guess let me do this. There's member AC, the only internal force we haven't solved for. So let's change that. That was 50 pounds in compression. I totally screwed that up, didn't I? Yep. So let's rewind. If I could, I would. And correct myself. That is not tension. We assumed tension, and we got negative 50. We assumed, I don't know what the heck I just said about 30 seconds ago, but what I meant was because we have a negative, our assumption of tension was wrong. That means that we have compression. Now let's look at this in the real world situation. We have this member BC and member AC. Those two are feeling this 50-pound force. So imagine yourself pulling down 50 pounds at joint C. You could imagine in real life that would actually be trying to, and eventually it's squishing AC together. It's kind of creating a compression. I can't imagine that it would be stretching AC in tension. So when we come back here, we can see that our, oops, that's weird, there, that our internal forces represent that AC is in compression 50 pounds. So really the last thing we want to do, the kind of the final step in any of this, is just drawing a final free body diagram. So we'll call this our final free body diagram. And you would want to do this by hand and draw, you've got A, B, C this way. We've got 50 pounds this way. We have our other reaction force 50 this way. We also have vertical 50 pounds this way, and our applied load 50 pounds that way. So our roller just gets the one horizontal, our pin gets vertical, horizontal. They all ended up just being 50 pounds. And then let's label this. These are A, B, and C respectively. So member AB we decided had 0 pounds. That was a zero force member. AC we just found was 50 pounds in compression. And member BC 70 point, was it 71? And that was in tension. So we have our reaction forces, our external loads that were already applied, and our internal loads. So this is our nice final free body diagram that sums it all up for us. So there it is, just over 5 minutes. But hopefully you enjoyed that. And if you have any questions, if you're in my POE class, give me a holler. We're back in person tomorrow. Otherwise, add a comment, hit that like button, follow, all that good stuff. But anyways, thanks again to my followers, specifically David Lance. Always appreciate the comments and the support. And I will see you guys next time.